Okay, pre-calculus, here's your notes for 2.8. We're going to be talking about operations among functions today. If you have two functions that are subtracted, let's try that again. Two functions that are subtracted, we define that as f of x, and we simply subtract g of x. The domain would be the domain of domain of f intersected with the domain of g. Is that a plus on your sheet? I can't tell with this. Let me try again. Oh, I'm sorry. It's a plus on yours. Sorry. So we'll change that. So f plus. There we go. Okay. If we subtract, same thing happens. F of x minus g of x. Your domain again would be f intersect domain of g. If the two are multiplied together, f times, or f of x times g of x, where your domain of f intersected with domain of g. And if you divide them, again, you could probably guess f of x divided by g of x, and the domain is domain of f union with domain of g. Note that you're dividing and g of x is on the denominator, so you have to exclude where g of x equals 0. Can't have where g of x equals 0. That's excluded from the domain. So we want to compute all of these things, f minus x, or f plus g, I'm sorry, f plus g, f minus g, so on and so forth. So f plus g will simply be x squared plus x minus 1. F minus g will be equal to x squared minus x minus 1, or x squared minus x plus 1. F times g will be x squared times x minus 1, which is x to the third minus x squared. And f divided by g will be x squared over x minus 1, which is simplified. Now let's state the domains. If you notice for both these functions, the domain is all real numbers. All real numbers. And since their domains are all real numbers, the intersection of their domains as well is all real numbers. Whoop. For the product one, it again would be all real numbers. But here's the problem. On the bottom, for this very last one, what number cannot be in the denominator? You can't have 1. So you would have x cannot equal 1 for your domain. Everything else would satisfy. So you know that's pretty much it. Not too big of a deal. So let's try a couple others a little bit more difficult. Let's try B. And give myself some room here. For B, f plus g, f minus g, f times g, f divided by g. Well, f plus g would just be the square root of 2 minus x plus square root of x squared minus 9. We can't add those together. The only way we could is if the radicants were the same, and they're not. So minus will be the square root of 2 minus x minus the square root of x squared minus 9. F times g will be square root of 2 minus x times square root of x squared minus 9. Now we can multiply the insides together. Note that if you have the square root of 5 times the square root of 7, that is the same as the square root of 35. We just multiply them together. So I guess on the inside there, what we truly have to do is going to be 2 minus x times x squared minus 9. And you get 2x squared minus 18 minus x to the third plus 9x, or negative x to the third plus 2x squared plus 9x minus 18. So if you multiply this out, we get the square root of negative x to the third plus 2x squared plus 9x minus 18. F divided by g would just be square root of 2 minus x over the square root of x squared minus 9. Now, what's really important here is that we identify the domain. Domain's a little bit trickier. I'm going to use a separate sheet of paper here. Let's see, we got 2 minus x. And we got, g of x is square root of x squared minus 9. Well, we know we can't take the square root of negative numbers. So therefore, 2 minus x must be greater than or equal to 0. When we solve for that, we get add x to both sides. 2 is greater than or equal to x. Or x is less than or equal to 2. So if you're to graph that, you have 2. X has to be less than that, or equal to. So we go that side. For this one, g of x is x squared minus 9. That means that x squared minus 9 has to be greater than or equal to 0. And if you were to graph that, you would say that it's down 9 units. It comes up through negative 3 and positive 3. Just like so. And so you realize that for g, x would have to be, where you look for where's the graph above the x-axis. Where is the graph above the x-axis to solve that, as we've done before? So x would have to be greater than or equal to 3, and x would have to be less than or equal to negative 3. Well, if you graph that, 3, which is greater than, and then negative 3, less than, it looks like the overlap doesn't happen until we get to right. Again, we're looking for the overlap for the domains. Where do they overlap? And they're going to overlap everywhere behind negative 3. Everywhere behind negative 3. So the overlap, or the domain of f, where the domain of f intersects the domain of g, is going to be where x is less than or equal to negative 3. That is the intersection. So a little bit tricky to figure out the domain, but you know, that's we do tricky stuff. So the domain is going to be x less than or equal to negative 3, x less than or equal to negative 3, x less than or equal to negative 3. But for the last one, note you can't have 0 in the denominator. And what numbers will give you 0 in the denominator? 3 or negative 3. Thus, the domain will be x less than negative 3. You can't be, you couldn't be equal to 3 down there. It will give you 0 in the denominator. So there's the list of all my domains. And we're good to go. Okay, let's do this last one. It says graph f of x equals x squared and g of x equals x minus 1. And use graphical addition to sketch f plus g and g minus f. So we'll do f plus g and g minus f. I'm going to put a few points up here. X squared, at 0 it's 0, 1 it's 1, 2 squared is 4, negative 1 is 1, negative 2 squared is 4, and I have this shape right there. And then x minus 1, let's see, at negative 2 it's going to be negative 3. Here's my graph of that line. And I want to add them. So what I do is I find points. So I'm going to look here. I'm going to add their points. So positive 4 plus negative 3. Positive 4 plus negative 3 is 1. Put a dot on 1. 1 plus negative 2 is negative 1. 0 plus -1, -1. 1 plus 1, 0 plus 1 is 1. 1 plus 4 is 5. And you can see that the shape that you get is going to be something like that. So when you add them together, that's the shape that you get when you do graphical addition. I'm going to do subtraction now. I'm going to plot the same thing, 0, 0, 1, 1, 2, 4. That's my shape. Now that I have that shape, I'll do the other one again. And this time I do subtractions, g minus f. So now I need to take -3 minus 4 is -7. -2 minus 1 is -3. -1 minus 0 is -1. 1 minus 1 is 0. 2 minus 4, I'm sorry, 1 minus 4. 1 minus 4 is -3. Oh, you guys probably caught me somewhere here. Where did I mix up? I'm sorry. Yep, right there. You guys saw it. We had 0 minus 1 was -1. Yep, so you can tell the shape that I'm going to get right here. So that's through graphical subtraction. Sorry about the little mix-up there. Got to really keep in mind your y values. You know, sometimes you want to use your x values, but that's how I do it. Your assignment will be given to you. Good luck, you guys. Do your best, and you know, any questions we have, we can go over tomorrow. Thanks.